as a 1. Okay, so what I have here is f of x equals 32x cubed minus 52x squared plus 17x plus 3. And what I want to do is show you how to find all the possible rational zeros by applying the rational zero test, and then to find all the rational zeros. So when looking at this, when applying the rational zero test, the first thing we want to do is determine our p and our q. And I'll show you what the p and the q is going to represent. But here is going to represent our p, and 32 represents our q. So if you can just remember, p is going to be your constant, and q is going to be your leading coefficient that you have. So then when we're talking about the p over q, what we're looking at is the factors. What we want to do is determine the factors of p over q, and it's going to be plus or minus. So one thing I might want to do is look at the factors of p, which would be 3. Well, the factors of 3 are pretty easy. It's going to be 3 and 1, right? Then we take the factors of q. Well, q is going to be 32. It's not as nice, but we can still figure them out. So we have 32 times 1. We have 16 times 2. We have 8 times 4. And 3, 4, 5, 6, 7, 8. That's it, right? So we have all these 4 factors. So what we're going to do when doing the p over q, we're going to take all the possible factors of p and divide them by all the possible factors of q. And we have to make sure we include the positive and the negative of each one of these factors. So therefore, the factors of p are going to be 3 and 1. And the factors of q are going to be 32, 16, 8, 4, 2, and 1. Right? Those are all the factors of q. These are all the factors of p. So what they're going to do, remember rational, talking about fractions, rational, what we're going to do is determine all the possible rational zeros. If these are just going to be, if it's going to be a rational zero, then it's going to become, it has to be one of these rational zeros. Therefore, you can see, I'll explain here. So if I do plus or minus p over q equals, now what I do is I just pretty much go down the list. You could do plus or minus 3 over 32, plus or minus 3 over 16, plus or minus 3 over 8, plus or minus 3 over 4, plus or minus 3 over 2, plus or minus 3 over 1. And then continue on, plus or minus 1 over 32, comma, plus or minus 1 over 16, comma, plus or minus 1 over 8, comma, plus or minus 1 over 4, comma, plus or minus 1/2, comma, plus or minus 1 over 1. So you can see out of the total number of possible zeros, without simplifying in them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. However, ladies and gentlemen, we have a degree of 3. So we know there's not 12 zeros, right? But if there is a rational zero, it has to be one of these rational numbers. That's all pretty much the rational zero test is telling you. It's not going to be 1/3. You can see 1/3 is not a rational zero here. So a zero of this is not going to be 1/3. Now let's go ahead and simplify this just so it makes a little bit more sense. Plus or minus p over q, a lot of times when I'm writing these, I'll just do the plus or minus on the outside, so I don't have to write plus or minus for all of them. And then let's just go and simplify this. 3 over 32 we cannot simplify, so I'll just leave that as 3 over 32. Can't simplify 3 over 16, nor can I do 3 over 8. Not plus or minus, already multiplying. 3 over 8, 3/4, 3/2. I can simplify 3 over 1. That's just going to be the number 3. And then we have 1/32, 1/16, 1/8, 1/4, 1/2, and then 1. Okay? So that, ladies and gentlemen, is a list of all of your possible rational zeros. Now, what are you going to do with this list? All right? So what the other part of the question was to find what are all the remaining zeros. So what are your possible remaining zeros? Well, if you look at this, there's some pretty crazy rational numbers, right? You have 3 over 32. You have 1 over 16. When I gave you a problem and I said, hey, here's a 0, what do you do with that 0? You apply synthetic division. Well, you're not going to want to apply synthetic division to all of these numbers, right? That's just going to be way too much synthetic division. So there's 2 ways you can do this. If you don't have a graphing utility, I recommend using the easiest number first. I would recommend doing synthetic division. Now remember, this is all plus or minus. So I would recommend doing synthetic division with positive 1 and then negative 1. And remember, if you do synthetic division and you get a remainder of 0, then that's a 0. However, I used a graphing technology, and I was able to determine that 1 actually was a 0. Let's actually show that. I'll actually do it for both of them, just because I like doing math. So let's pretend you don't have graphing technology, and you're saying, you know what? Let me just go ahead and choose. Let me go and see if 1 or negative 1 is a 0, because I don't really want to do synthetic division for all these. So therefore, you pick 32, negative 52, 17, and 3. And then you say, you know what? I bet if 1's a 0, maybe negative 1 will be a 0 as well. 32, negative 52, 17, and 3. So therefore, we now do synthetic division. Bring down the 32. 32 times 1 is 32. That's going to be a negative 20, negative 20, negative 20, negative 3, negative 3 becomes a 0. So yes, that's actually this actually 1 is actually now a factor, right? And that's very cool. Let's see if negative 1 is a 0. Bring down 32. That becomes a negative 32. That becomes a negative 84. Negative 4 times positive, that becomes a positive 84. 91, that's a 101. Negative 101. Now that has a remainder, so therefore negative 1 is not a 0, right? Now you can keep on doing this for every single one of these, but we already found one that works, right? So now what we next need to do is, so we found our factors, and pretty much now what we have is we know that now x, if this is a 0, that means x minus 1 is a factor, and this is going to be my other resultant, which will be 32x squared minus 20x minus 3. And that times that equals my function. But if I want to find all the remaining zeros, I have to set this equal to 0, right? And now I have to be able to go ahead and solve and see what that's going to be. So, factoring that, oh man, that just doesn't even look fun. So one thing you can do, if here's all my rational zeros, hopefully everybody wrote that down, is you can always go back to, so we know that's a 0. You could factor the 32, I guess we could see. That's going to be, let's see, 64, 96. What two numbers give you 96? This can be in the factored form. Right? Now we have to factor these because now we have to solve for this. We know we figured out that that's a 0. 1 is a 0, so that's its factor. Now I need to factor that. So let's see, that's going to be 32, 64, 96. So what two numbers multiply to give you 96, but then add to give you negative 20, or multiply to give you a negative 96. So let's see, 96. So you have negative 48 and 2, right? You'd have a negative 24 and 3. That would be your best bet. 24 and 3, you have 24 and 4, not 4, 3. You're right, 4. Thank you. So yeah, these two work, right? So you do negative 24 and 4. So then if I was going to rewrite this, it'd be x minus 1 times 32x squared minus 24x plus 4x minus 3 equals 0. Then I can factor this. So by factoring this, remember now we need to factor by grouping. Yep. You're like, oh my God, this is such a long problem. So now factor by grouping, you say, what does 32x squared and a negative 24x squared? I'd probably say they're going to have an 8x. Pull that out, so therefore you'll be left with a 4x minus 3. And then over here, you can just factor out a positive 1 and left with a 4x minus 3. Therefore, you have x minus 1. And let's set these equal to 0. X minus 1, now you pull out a 4x minus 3, and you're left with a 8x plus 1 equals 0. Now you apply zero product property. We already know that 1 was a 0. So therefore, x equals 1, x equals 3/4, and x equals a negative 1/8. OK? Ta-da! You won't have, that's just for the video. You guys won't have anything.